All right, guys, so here is one numerical example. So I have two agents, Bob and Ray. They are roommates, and they are considering buying a sofa, and this sofa, they're going to put it in the living room, so it's going to become a public good. All right? So I have the Bob's utility function and the Ray's utility function. So here, rather than G, I have S as the notation, so it's the sofa. So the sofa is either 1 or 0, so they either buy the sofa or not. So if S is equal to 1, it means they buy the sofa. If S is equal to 0, they don't buy the sofa. So if you look at the Bob's utility, his utility depends on his private consumption and whether they own the sofa or not. So it's 1 plus S times the private consumption. So this is, in a sense, Cobb-Douglas type of utility function, right? X times Y, in a sense. And this is the Ray's utility function. Initially, Bob has $100 and $100 to spend between the private consumption and the public good consumption. The Ray has $70. And the cost of sofa is $70, all right? So they can actually afford. I mean, the Ray can buy the sofa. I mean, he has the money. But the question is he willing to buy the sofa? That's another question, all right? So once again, both Ray and Bob separately have the money to be, I mean, they can afford the sofa. They can buy the sofa. But the question is, are they willing to buy the sofa? Well, that depends on how much money they're going to pay for the sofa each and their reservation price. All right, so we can't really answer that question without solving the reservation price. So the question asks a bunch of questions like, what if they split the cost equally, meaning the Ray pays 35, Bob pays 35? What if, for example, Bob pays everything and Bob pays everything, Ray pays nothing, yada yada. So there's a bunch of part A, B, C, D. I'm going to skip all those. Maybe towards the end I'm going to make a general argument about how to answer those questions. But what I'm going to focus on, which is the key point, is one, what is the reservation price for Bob? All right, and Ray, so reservation price for Bob and the reservation price for Ray. All right, what are they? Is it efficient? RB plus RR. Is it efficient? Meaning, is it greater than or equal to $70? All right, and then who should pay how much? All right, so what are the Pareto efficient way of providing for public good? Okay, so first thing first, let's find the reservation prices. Remember, let's look at the Bob first. For the reservation price, we compare two utility values. Utility under which the Bob doesn't own the sofa, meaning the S is equal to 0. Therefore, he spends all his money, which is WB dollars, for his private consumption. All right, so XP equals WB. So he has $100. So if he has no sofa, so S is going to take, so this is the utility function for Bob. So S is going to take value 0. So it's going to be 1 times XB. And so XB is going to be equal to his, all his money, which is 100. So therefore, the Bob's utility, if he doesn't own the sofa and spend all his money on private consumption, his utility will be 100. So this is his reservation utility, all right? So this is his bottom line. You can't give him less utility than this, all right? You can give him more utility than this by providing this guy a sofa, all right? So this is exactly what we do. Well, what if he has a sofa? Well, obviously now he's going to make some payment towards the sofa. So he's going to have WB minus RB, which we don't know yet. Okay, so what is his WB? It's $100. So S is equal to 1, so this is going to be 1 plus 1, 2 times XB. So what is XB? 100, which is his wealth, minus RB. Okay, so this is his utility, if he pays RB dollars, and this is the, well, in order to find the maximum amount of money that he's willing to pay, we basically set them equal. All right, so 100 equals 2 times 100 minus RB. Okay, so it's 50 equals 100 minus RB. So RB equals $50. So that means the Bob's reservation price is $50. All right, so RB, so let's write it here. RB is equal to $50. What does that mean? That means Bob, yes, he owns twice more money, but you know what? It's not worth it to spend more than $50 to own this sofa. Okay, so think about it. I mean, I will calculate Ray's reservation price, but think about the following. So let's say Bob pays $70 for sofa and he buys it. What is going to be his utility? Well, his utility is going to be, let's calculate. So he owns the sofa, so it's S is equal to 1, so 1 plus 1, 2, times XB. So how much money he can spend on private consumption? Well, he already pays $70 for the public good. So he already had $100. So 100 minus 70 is what's left for private consumption. So this is going to be his utility. What is this? Well, his utility is 2 times 30. So 60 units of utility. Okay. But the question is, what would be the Bob's utility if he actually does not pay anything for the sofa and hence doesn't own the sofa, right? So this is the worst case scenario. Think it that way. So this is the worst case scenario for Bob. I don't have a sofa, but you know what? I don't have to pay for the sofa, so I can consume all my wealth on my private consumption. So his worst case utility is 100. But if he pays for the sofa, his utility will be 60. So obviously it's rational for him not to pay $70 to buy the sofa. And which makes sense because $70 is higher than his reservation. In fact, for any price, for any G higher than RB, you calculate the utility, the Bob's utility is going to be lower than 100. All right? So once again, for any G, any money, any contribution that Bob pays to own the sofa, well, I mean, so here the Bob paid $70 because we assume the Ray pays nothing, but maybe Ray's also pays something. All right, so Bob doesn't have to pay the whole cost of $70. So maybe pays less, like $30, $40, I don't know. Any G. But the thing is, let's suppose this G is greater than the reservation price. Do the calculation, do the math. So for any G greater than RB, the Bob's utility, if he owns the sofa, is going to be lower than this 100 value. All right? So this is exactly why the $50 is the maximum amount of money that Bob is willing to pay. Okay? So if you're not convinced, which is fine, you have to spend some time, do some exercises here, and you must convince yourself why RB equals 50 is really the maximum price the Bob is willing to pay for the sofa. He has the money, but he's not willing to pay a dime more or a cent more than $50. Okay? Okay, I hope. So let's calculate the Ray's reservation price. So for Ray, the Ray's utility when he consumes all his money, which is $70, and no sofa. So this is his bottom line, the worst case scenario. So his utility will be 2 plus 0, so 2 times XR, which is 70, so 140 units of utility. While the Ray's utility, however, would be 70 minus RR. So this would be his the private consumption when he owns the sofa. In that case, it's going to be 2 plus 1, 3 times 70 minus RR. Okay. I wish I had picked. Well, I mean, I can still play with the utility functions, right? Yeah, I can do that. So, guys, I'm sorry for changing it in the last moment. So let's make this 2, 3. Okay. So that I don't have to deal with. Oh, once I make this, see what's going to happen. Yeah, that's going to change. Okay, so let's not make that change. Oh, well, okay, you know what? I don't want to make any changes on the spot, so let's leave it as is. So this is the raise utility function if he owns the sofa. So I didn't change anything in the utility functions. Well, how do I find the reservation price, right? I mean, these two things, 140 has to be equal to 3 times 70 minus RR. So, well, you solve it. So this is 210 minus 3RR equals 140. So I pulled 3RR to the left-hand side. I send 140 to the other side. If you do that, I think you're going to get 70. So RR is 70 divided by 3, which is, I don't know, $23. Yeah, something like this, $23 and, you know, etc. So it's not a round number. So 70 divided by, so the raise reservation price is 70 divided by $3. Okay? Good. Again, this is approximately $23. Approximately, all right? Slightly more than that. So the question is, I found the reservation prices. Do we have this? I mean, is the buying sofa Pareto efficient? The answer is yes, because the Bob's reservation price and the Ray's reservation price, which is 50 plus 70 divided by 3. I don't know what exactly this is, but approximately this is equal to $73, approximately, which is higher than the cost, which is $70. So, luckily, these guys are jointly willing to pay to cover the cost of sofa. But individually, none of them is willing to pay for the sofa. So Ray is going to say, hey, you know what? I am willing to buy the sofa, but I'm willing to only pay at most $50. And the Ray is going to say, okay, I'm also willing to buy the sofa, but I'm not going to pay more than 70 divided by $3. So that's the max I can pay. So they're going to make all these calculations and they're going to see, oh, you know what? If we in fact add up our reservation prices, it does cover the cost of sofa. So let's go and buy the sofa because it's efficient. I mean, it's better for both of us. It's a win-win situation if we buy the sofa. The lose-lose situation is like, well, we don't own the sofa. Well, the question is, who pays how much? I mean, for example, that's why part A, B, and C of this question is like, for example, do they share the cost of the sofa equally? Like 35 you pay and the 35, Bob pays and the 35 Ray pays. Is it efficient? No, it's not. Why not? Well, because if they split the cost equally, Bob is willing to accept that, all right? But the Ray is not, because the Ray, remember, is willing to pay at most $23 approximately. And we're asking him to pay more than that. So in this case, remember, his utility is going to be lower than 140. So he's going to say, oh, you know what? I don't want sofa. If I have to pay $35, I'd rather not have the sofa. Okay? So 35 is a deal breaker. So 35 is not going to happen. Okay? So then the question is, what is or are Pareto efficient way of financing this project? Well, there isn't one. Well, one is, for example, Bob pays $50 and the Ray pays the rest, $20. So collectively they covered the cost, and so this is Pareto efficient, obviously. Okay? Well, but the Bob is going to say, well, why do I pay $50? Well, what about this? I pay $47 and Ray, you pay $23. How about this? Well, remember the Ray's reservation price is approximately $23, slightly higher than that. So Ray is going to be okay with it. I mean, he's not going to switch and say, oh, you know what, screw you, I don't want sofa. In fact, he is going to say, oh, you know what, if I pay $23 and we own the sofa, my utility will be higher than $140. Again, do that as an exercise and convince yourself, all right? So let me do it very quickly. So Ray pays $23. So in that case, his private consumption is going to be 70 minus 23, all right? And they own the sofa, so S is equal to 1. So what happens is 3 times 70 minus 23, which is equal to 47. So if you do this multiplication, it's 141. You see, it's higher than this bottom line utility level. So Ray is going to be okay with paying $23. Bob is obviously, well, he was okay paying $50. He will be definitely happier of paying $47. So this is also Pareto efficient. Well, you can actually say why it is 47-23. What about Bob pays 48, Ray pays 22, I'm sorry. This is also Pareto efficient. Sum up $70 and the reservation prices are above those contribution levels. So they both are willing to pay those prices. So these are also Pareto. So as you see, there are infinitely many ways of distributing the cost of sofa between these two agents. And in fact, if we need to find all Pareto efficient contributions, is the following. So let's call it G1, G2, okay? So G1 has to be less than or equal to, who is 1? I'm sorry. The Bob's contribution should be less than the Bob's reservation price, which is 50, all right? The Ray's contribution should be less than the Ray's reservation price, which is 70 divided by 3. And importantly, their contribution, the total contribution should exceed the cost of sofa, which is 70. So as long as GB and GR satisfy these 3 conditions, it is Pareto efficient. Okay? Well, in fact, I should say this has to be the case. Why? Well, because, for example, Bob paying, say, $50 and the Ray paying $23, this is not Pareto efficient. Okay, why is that? Well, first of all, both Bob and Ray are willing to pay those prices because those prices are below or equal to their reservation price. Okay, so Bob is happy, Ray is happy. But the thing is, the sum of their contribution is $73, which is more than the sofa. I mean, why? Well, the question is, what happens to this additional $3? Well, let's say this $3 is wasted. I mean, the sofa is there, $70, pay it and get it. But these guys are just going to the sofa seller and pays him $73. The sofa seller is obviously going to say, oh, thank you. So it's like $3 is a tip. Tipping is a delicate issue, I know. But so they are paying more than what the cost of the sofa is. So here, in fact, there is a better allocation where Bob pays only, again, $50, so his utility will be same, and the Ray pays only $20, all right? So When it compared to this versus this, Bob is indifferent, but the Ray is going to be happier here. So therefore, this is inefficient because it's possible to make one agent better off without hurting the other agent. So this is Pareto inefficient. This is Pareto efficient. So for that reason, all Pareto efficient contributions, GB and GR, should be such that they are less than the reservation prices and they sum up to exactly the cost of the public good. I hope that was clear.